Okay, let's get started. Unit 7, Video 2. Grab those vocab books. This is going to be a short lesson. Okay, today we're going to talk about similarity with inscribed triangles. So, if you take a look at this triangle, triangle ABC, notice that there's another triangle inside of it. That triangle is called an inscribed triangle. It's inside of another shape. It's inside of another triangle. So, when this happens, and the two triangles share an angle, like this one, and the two sides of the triangles are parallel, like these two are, then you have similar triangles. So, that's what we're going to be working with today. Solving for sides of similar triangles that look like this, inscribed triangles. So, go ahead and go to your notes. Let's get started on some problems. Okay, be sure to write your title and write the problem, draw the picture, label all the sides. So we're going to be trying to find x for these similar triangles. So let me go ahead and put a spot for my answer. X equals. Now, when you have the triangles like this, it's kind of hard to figure out what sides are corresponding. What goes with what? How do I set up a proportion to solve for the missing side? So your best bet is to take your two triangles and separate them into triangles that are not inscribed. So you just redraw them like so. Okay, so imagine separating them. Then you just go ahead and label all of your sides. So the smaller triangle had side 12, 10, and 15. Okay, and then the larger triangle had a 20 here. Now we have to be really careful with when we're labeling the other two sides. If you look at this side, what is this side length? Well, from here to here is 10, and from here to here is 5, so this length would have to be 15. So this length is 15. Now, if you look at this bottom piece, from here to here is 12, and from here to here is the value of x, which we're going to be figuring out. So what would the whole length be? Well, what is 12 plus x? Well, we have to go ahead and keep them separate. So we'll write it 12 plus x. Okay, so now we have two triangles that are similar. Hopefully it's easy to see which sides are corresponding. Okay, I'm going to label it like this. These are the corresponding sides. You can use shapes like we normally do, or different colors. Circle them in different colors. So let's set up a proportion with our values. So I'm going to go ahead and use the 10 and the 15, and then I'm going to have to use the 12 with the 12 plus x. Okay, because I'm solving for x, my second one, I'm going to need to have a variable in it. So let me set up my proportion. 10 goes with 15, and 12 goes with 12 plus x. Okay, now we just have to cross multiply and solve for x. So why don't we go ahead and reduce this fraction? Make our life a little bit easier. So 10 over 15, if you divide by 5, you get 2 over 3. Okay, that's an ugly 3. All right, good enough. Okay, now we can go ahead and cross multiply, and we're going to get 2 times 12 plus x equals 3 times 12, or 36. Distribute, so 24 plus 2x equals 36. Subtract 24 on both sides, and we get 2x equals 12, which means that x equals 6. So we solved for x, which was what we were asked to do. So let's go ahead and write our answer over here. X equals 6. Okay, on to problem 2. So problem 2 is pretty much the same thing. We have our 2 triangles, one inscribed in the other. We have this one inscribed in this one. So we're going to go ahead and draw them separately. So we'll draw our smaller triangle and then our larger triangle. And let's not forget to put a spot for our answer. We're trying to find x, so I'll put that over here. X equals. Okay, so let's label all the sides of our triangles that we have. Okay, so for the smaller triangle, we know that this is 16 and the side is x plus 4. Now for the larger triangle, the bottom, the base is 20. And what would the side be? What would this side length be of our large triangle? Okay, well, it would have to be this piece plus this piece. So we would have to put x plus 4 plus x plus 10. So that would be 2x, whenever we combine like terms, plus 14. Okay, so now we can go ahead and set up our proportion. We know that 16 goes with 20, and x plus 4 goes with 2x plus 14. So I'm going to go ahead and set up a proportion and solve for x. So we know that 16 corresponds to 20, and x plus 4 corresponds to 2x plus 14. Okay, why don't we go ahead and reduce that 16 over 20 to divide by 4. We're going to reduce it to 1/4. You don't have to reduce. I don't want to work with those big numbers. So when we cross multiply, we're going to get 4 times x plus 4 equals 1 times 2x plus 14, which is just 2x plus 14. Okay, distribute. So 4x plus 16 equals 2x plus 14. Okay, let's get our variables to one side. So I'm going to go ahead and subtract 2x. So 2x plus 16 equals 14. Subtract 16 on both sides. And we get 2x equals -2, which means when we divide by 2, we get x equals -1. So we can go ahead and plug in our value of x, which is -1. If you needed to know side lengths, like side BE, then you would just put in -1 and we would get 3. -1 plus 4. So this length would be 3. Nothing's drawn to scale, of course, but we could still get the answers if we wanted. All right. See, I told you that was a quick lesson. I hope you have an awesome day.